All right, so we're going to look at our LCD here, m squared and m squared. The LCD is at least as big as the smallest thing. At least as big as the biggest thing. The biggest thing is m squared. That's our LCD. All right, we're going to multiply this entire equation by m squared. So here we have 4 times m squared over m squared plus 1 times m squared over m is equal to 1 times m squared over m squared. Reduce any of these fractions that you can. This is 1. This is m squared over m is just m, so I'm going it to be m, and that's 1. 4 times 1 is 4 plus m equals 1. Subtract 4, m equals negative 3. Check to make sure that doesn't make anything 0. Negative 3 times negative 3 is 9. And then negative 3 in the denominator is also okay. So just as long as 0 is not the result of the denominator, you're okay. All right. Factor any denominators that you have. The GCF is x minus 6, and then this one also factors the same exact way, x minus 6. So my LCD is x times x minus 6. All right, x times x minus 6. Okay, we're going to multiply everything. Oh, so it's at least as big as x times x minus 6, and then we look and see that the other denominator has x minus 6. That is the exact same as x minus 6, so you're okay. X times x minus 6. So again, I'm not really multiplying, I'm just putting it next to each other. 2 times x minus 6 over x minus 6 plus x times x minus 6 over x times x minus 6 equals 3 times x minus 6 over x times x minus 6. All right, a lot of these are going to reduce. 1, including that x. All right, so now we have 2x plus 1 equals 3. Wow, nice. 2x equals 2. X equals 1. Check to make sure that does not make any of my denominators 0. 1 minus 6, that's not 0. 1 minus 6 times 1. That's also not 0. Good to go. If it makes a denominator 0, it is called an extraneous solution and is not actually a solution. So don't you dare box it in if it's extraneous. All right. Factor all your denominators. This we can use p's and q's. 4 and 5 add up to give me 9 and multiply to give me 20. My LCD is definitely at least a plus 4 times a plus 5. And that does take into account this denominator as well, so we're good to go. Multiply by the LCD, a plus 4 times a plus 5. Anything that's in a numerator needs to be grouped because it's all being multiplied by the LCD. First, I have this times 1. A plus 4 times a plus 5 over a plus 4 equals a plus 4 times a plus 5 times a squared plus 6a over a plus 4 times a plus 5. So much going on here. And then plus a plus 4, a plus 5 times 3a minus 15 over a plus 4, a plus 5. Wow, it's going to be nice when these all reduce. Okay, so it doesn't even fit in my screen. Okay, a plus 4 over a plus 4, a plus 4 over a plus 4, a plus 5 over a plus 5. Done, done. Woo! Now we have a plus 5 equals a squared plus 6a times 1 plus 3a minus 15. All right, so we're going to be solving a quadratic. You have a square term here. I want the square term to be positive, so keep it on this side. Move everything to this side, combine like terms, because we want it to equal 0 so we can try to factor and use the zero product property. So subtract a. Sorry, I'm going to actually combine like terms first. So a plus 5 equals a squared plus 9a minus 15. I'm going to subtract a from the a column, subtract 5 from the number column. 0 equals a squared plus 8a minus 20. All right, you can factor this with p's and q's. A, and then it's not 4 and 5. That's my go-to for 20, so let's try 10 and 2. A, all right, so if you have a positive 10 minus 2, then you'll get a positive 8a. And you have positive 10 times negative 2, then you get a negative 20. Use the zero product property to solve. A plus 10 equals 0. A equals negative 10. A minus 2 equals 0. A equals 2. Make sure none of these are extraneous. Don't box them in yet. You've got to check. Okay, if I plug in 2, 2 plus 4 is 6. That's okay. If I plug in 2, 2 plus 4 is 6 times 2 plus 5 is 7. 6 times 7 is not 0. Yay. Okay, so 2 works. That one was kind of easy to plug in. Now negative 10. Negative 10 plus 4, not 0. Let's try this one. Negative 10 squared is 100. Oh, let's plug it in here, actually. Negative 10 plus 4 is negative 6 times negative 5. Also not 0. Good. Both of them are answers. That may not be true on the test, so you have to check. Please check to see if anything makes a denominator 0. If it does, it is not a solution. Do not box it in or label it as extraneous. All right, the last one, I'm just going to do one of these graphing ones, so pay attention. Okay. I need to know what A, H, and K are. This is in the form A over X minus H plus K. All right, A is 4, H is positive 1. Change the sign for H, keep it for K. K is negative 2. All right, your vertical asymptote is X equals H. Your horizontal asymptote is Y equals K. Graph those as a dashed line or with a highlighter. Now you have a framework for your branches. This is a positive function. There's no negative in front of here or on here. So your branches will open toward the first and third quadrants. But plugging in the points usually helps too. This one's negative, so your branches here will open toward the second and the fourth quadrants. All right. Then we need to find the x-intercepts. X-intercepts are found by making f of x equal to 0. So I'm going to do that on this page. 0 equals 4 over x minus 1 minus 2. So first add 2 to both sides. 2 is equal to 4 over x minus 1. So you're going to multiply both sides by x minus 1. Make sure you distribute this 2 in. 2x minus 2 is equal to 4 plus 2. 2x equals 6. X equals 3. So my x-intercept is 3. X-int 3, 0. Plot it. Domain and range. I like to do domain and range after I've graphed it. We're going to plug in 2 points to the left and 2 points to the right of the vertical asymptote. All right, so the points that I want to plug in are 0 and negative 1. And 2. Just pretty much the ones closest to the asymptote. They're going to have the smaller numbers. It's just going to be easier. All right, so we're going to plug that in over here. F of negative 1 means we plug in negative 1 for x. 4 over negative 1 minus 1 minus 2. This is equal to 4 over negative 2 minus 2, equal to negative 2 minus 2, equal to negative 4. All right, plug in 0. F of 0. Plug in 0 for x. All right, so you have 4 over -1 minus 2 is -4 minus 2, -6. All right, let's plot these points as we go. -1, -4, 0, -6. And now we're plugging in 2. F of 2. 4 over 2 minus 1 minus 2. 4 over 1 minus 2 equals 2. 2 goes up 2. All right, your branches should hug but not cross your asymptotes. All right, domain is all real numbers. X is an element of the set of all real numbers, but X cannot equal whatever my vertical asymptote is, which is 1, the range. Y is a member of the set of all real numbers, but Y cannot equal the horizontal asymptote, which is -2.